Chris, can you give us a little bit of a tour of the spacecraft?
Sure. Come on, Chief Engineer, Scotty.
So, this is Arkyd Series 100 Space Telescope. It's the 102 actually, and we're working on this stuff actually faster than our animators and press people can keep up. We've got the main optic, and really this is all where all the action happens. It's a telescope, it's in space. We use this optic not only to take pictures, we use it to help point our spacecraft and to be able to point it very accurately so we can use laser communication to go from deep space all the way back to Earth. That's a new technology that has been talked about for a long time. It's been demonstrated. NASA is investing a lot of money in this, and we believe it's a key to enable commercial space exploration so that we don't need the huge infrastructure for deep space communication. This thing folds up.
That's a great question.
All right.
No one asked it.
Yeah.
Look it up,
Yeah,
type it in, and see if you find something.
So
Yeah.
what does Arkyd mean?
So what does Arkyd mean? And that is a name that is drawn from science fiction. We're big fans of science fiction. And the true fan of science fiction will be able to find the reference and appreciate what it means.
Oh, I'm going to tell him.
No.
From the Alien movie?
You guys seem to be having a great time.
Yeah, this is amazing. No, this is where our dreams.
Yeah,
I mean, what could you possibly work on in the space arena and have more fun than this?
Yeah, I've worked with NASA and at JPL and had great and tremendous opportunities and fantastic experiences, and they're doing great work. I've participated in the landing of 3 spacecraft on Mars, and recognizing that we're just announcing what we're doing today, the difference between landing on Mars and the difference about what our company is going to go off in the future that we'll create, it's that sense of hope that I talked about, and it's a distinct feeling from landing on Mars.
Here's a fundamental question. When this started to leak out the last couple of days, people were going, these people must be nuts.
Oh, we are.
You're what, a doctor?
We are
all
nuts. We are crazy. We're doing audacious things. We know it,
The
but
day before something is truly a breakthrough, it's a crazy idea.
yeah,
That's what it amounts to.
yeah, own
Well,
it.
I mean, we've done these crazy ideas over and over again. The idea of personal space flight, the ideas of all of the projects that we've cumulatively worked on were of course impossible before you showed them, before you did that. And this is something which the laws of physics don't prohibit it. The capital is available. The market is gigantic. Is it going to be hard? Absolutely.
Yep.
Can we do it? No question.
This
Yeah.
is the Arkyd 100.
This is Arkyd 102, actually. It's
102.
in our series of 100 spacecraft, and this is our technology demonstrator and a capability that we use in low Earth orbit. Our first opportunity to start learning how to use new approaches, new technologies, new techniques to just dramatically reduce the cost of space exploration. And what's unique about this is its size and how we can fit it on the cubby holes in rockets that we don't have to buy the entire rocket for. So, doors over here, but this folds up, and this can go in just a tiny little corner of a launch vehicle, and we can actually fit multiples on an individual launch vehicle. We can launch 3, 4, 5 at a time. And having 5 spacecraft in orbit, orbiting the Earth, allows you to do something what you could not do with 1 spacecraft, and that is to be able to go over Seattle at 10 after 11, 5 minutes later, go over it again, 5 minutes later, go over again. Remember, these things are traveling 28,000 miles an hour in orbit, and they are only over a particular spot in the ground very briefly. So if you can get that revisit time, you now start to get some time series information on what's going on the surface of the Earth. And with the element of time, you know how much more you can learn about that.
So its primary purpose is as a telescope.
Yes, it's a telescope, a technology demonstrator, and allows us to perfect the capability that we will then add propulsion capability to leave Earth's orbit, and then complete our deep space communication capability so that we can communicate with low-cost capability deep into space.
How much pointing ability does this have?
Yeah, there are actually no rockets on this. This has no propulsion. What you're seeing here are star cameras. This gives us very precise pointing information on where we are oriented in space. And the way that we point these in space, we use a thing called reaction wheels, or control moment gyros. And if you see the ballerina or the ice skater spinning real fast, she stretches out her arms and slows down, you can use that property of physics in space to point something. And we're working on with research institutions on technologies that will take that basic stability and make it very fine pointing stability, sub-arc-second pointing capability that will allow us to point a very fine beam of light back to Earth and send our data back to our mission control.
So you have an avionics system, you have gyros that help keep it stable, you have
lived my whole life running for these moments to come. Where
batteries,
40 years,
truck rods, other things that help, and you've got
what are we waiting for? Why are we going out into space?
a small spacecraft that keeps out.
Where's that?
That's the CubeSat right there.
Oh, okay. So it's a CubeSat. What is that?
Yeah, so if you look that up, it'll be a CubeSat is a small, very small package spacecraft that has been a standard in the nanosat industry for quite some time, and we wanted the ability to carry that with us.
Had a number of different jobs. One of the interesting.
Okay. And then this is the telescope over here.
Yes, that's our primary optic, which we'll use for communication as well as imaging.
Okay. Dumb question, but solar panels?
Yes.
Okay. Can it completely self-power?
Yeah, that's the idea of the spacecraft is that they are all an autonomous system that can be commandable.
Now, I know this is a demonstration unit, but could this actually go into space?
So this is, like you say, it's a demonstration unit, but the design is there. The design is the same. We use this architecture.
Couldn't just wait for the government. Your name again?
We designed it as if we were going to fly it. So that's what we use.
Great.